Hello everyone. Today we are going to go over some practice problems with permutations and combinations and also learn some formulas that'll help us out when working on problems related to permutations and combinations. So to start off, we learned about permutations and combinations in our last video looking at the burger versus the salad. Our first example problem is looking at 10 first graders lining up for a fire drill. So first we're being asked how many possible arrangements are there? So to find the total number of arrangements of this line of first graders, what we can do is think about, well, we have 10 spots in this line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for each spot, we could start off and ask ourselves, how many possible ways are there to fill this first spot? Well, we have 10 first graders, so there's 10 different students we could put in this spot. So we have 10 different ways to fill up this first spot. For the second spot, we've already put one of the students in the first spot, so we only have 9 students left. So we have 9 students left over that we could put into that spot. And each time we go down the line, there's one fewer student to put into the spots in lines until we're finally left with just one student at the end left over for that last spot. To find the total number of arrangements, what we would do is take all of these possibilities and multiply them all together like that, which might look a little familiar from our last video. So this is another way to write 10 factorial. We're starting with 10, and then we're going down by 1 and multiplying all of the numbers by going down all the way until we get to 1. 10 factorial in this case gives us 3, 6, 2, 8, 8, 0, 0. So a little bit over 3,628,800 different ways to line up these first graders. So that's a lot. Number 2, we're looking at how many of these arrangements have Calvin and Phoebe next to each other. So this type of question is a little difficult if we don't know what to do. What we're going to do for number 2 is we're going to look at a different way to think about this, to group Calvin and Phoebe. That'll make it easier to answer the question. So we're looking at Calvin and Phoebe being next to each other. What I'm going to do is think about, here's Calvin maybe, here's Phoebe. Calvin, Phoebe. And think about Calvin and Phoebe as one group. So instead of thinking about them separately, if we're putting them together, we're going to think about them as one group, Calvin and Phoebe. And then we have the 8 other students over here. So here we have the 8 other students for a total of 10 students. So we can go through the same process we did in number 1, thinking about this grouping of students. We could start off. So in the first spot, we could put Calvin and Phoebe, or we could put any of the 8 other students. So in the first spot, we have 9 different ways, 9 different groups or elements that we could put in that spot. In the second spot, we have 8, because we've already put either Calvin and Phoebe in the first spot or one of the 8 other students. Next, 7, 6. So each time we remove one of the students or that pair of Calvin and Phoebe. 5, 4, 3, 2, 1. So as you can see here, we have 9 factorial. And so we have 9 factorial, and we're almost done. One thing to consider, though, is we're looking at Calvin and Phoebe next to each other. And for all of these, because we're looking at a line, these are permutations. So the order does matter. So Calvin could come first before Phoebe, but also Calvin and Phoebe could be switched around. So we'll also consider another grouping where we have Phoebe to start, and then Calvin is behind Phoebe, and we're grouping these as one group. And then we also have the 8 other students that we're lining up, 8 other students. So the number of ways we could line these students up can be found using the exact same method we did down here. So we'll also get 9 factorial. So for number 2, the number of possible ways to line them up is 2 times 9 factorial. which gives us 725,760 ways or arrangements where Calvin and Phoebe are next to each other. For number 3, we're looking at probability. So far we've just been counting the number of ways, and it's asking us, what is the probability that Calvin and Phoebe will be next to each other? Well, for this problem, what we can do is take the number of outcomes or arrangements in our event and divide that by the number of outcomes in the total sample space. So in our event, then being next to each other, we have 725,760 ways the line could have them next to each other out of a total of 3,628,800 total possible arrangements. If we type this in our calculator, we end up with 0.2. So as a percentage, that's a 20% probability that Calvin and Phoebe end up next to each other. Okay, so moving on, let's take a look at another practice problem. Here we're looking at the word Shrek. So we have 5 different letters or elements in this word, and we're trying to find the probability that there is an E in the 3rd position and that the word ends with an S or an R. So we want to go through kind of the same set of steps that we did in our first problem. First, we want to find out the total number of ways to arrange these 5 letters. And we can do that by thinking about, for the first spot, there's 5 different letters we could put there. For the second spot, there's 4. For the third spot, there's 3, 2, and 1. So the total number of ways that we could arrange these is 5 factorial, which is equal to 120. Yeah, 120. Next, we want to think about, so our specific situation we're looking at is an E in the 3rd position, and the word ends with an S or an R. So let's set up our 5-letter word, 1, 2, 3, 4, 5. The E has to be in the 3rd position, so there's only one letter we could put there, and that's the E. And then for the S or the R, there's 2 different ways we could fill in that last position. We could put an S there, or we could put an R there. And then we're going to go ahead, start at the front, and then think about the number of ways we could fill out the rest of those spaces. So if we placed an E and then an S, for example, then we have 3 different letters that we could put in this first spot. Next, we have 2 letters remaining that we could put in these 2 spots. And then finally, there's 1 letter left over here. And it's the same number if we had an E and we started with an R instead. So we filled out these 2 spaces first, and then we filled out the rest of the spaces like we did in number 1. Finally, to find the number of different ways we could arrange the word like this, we just multiply these numbers together. So 3 times 2 is 6, times 2 is 12. So we have 12 different arrangements of these letters so that there's an E in the 3rd position and an S or an R in the last position. Finally, for probability, we're looking at probability, let's call this event A. We're looking at the number of outcomes or arrangements in our event divided by the total number of outcomes or arrangements, which we can see is 10%. So in this problem, we're looking at the difference between permutations and combinations. So we're looking at the word bra. Number 1, we're looking at how many ways are there to order these letters into groups of 3. And then number 2 is how many ways are there to group these letters into groups of 3. So scrolling down, we have down here, we've listed out all of the different permutations of the word bra. And what I've done here is I've grouped the letters up, and we're looking at groups of 3, into 4 different combinations. So each of these is a combination because they have, or is a different combination because they have 3 different elements or letters from the word bra. For example, if we look at the first combination, so these are combinations. The first combination has the letter B, R, and U. And going to the right, I've just switched the order of B, R, and U. The second combination has R, U, and H, so we're missing B in this case. For the third combination, we're missing that R. For the fourth combination, we're missing the U. So 4 different combinations. All of these words, though, 3-letter words, separated by commas, are permutations. So we have 4 different combinations. The number of permutations is going to be all of these 3-letter words which we have 1, 2, 3, 4, 5, 6 rows, 6 columns, 4 rows. We have 24 permutations of the word bruh. So as you can see, there's a big difference between the number of combinations for this word. In other words, the number of groups of letters and the number of permutations, the ordering for this word. So a real bruh moment right here.